Now, in the order of image processing techniques, in this video we are going to talk about thresholding, implementation using OpenCV in Python. So before proceeding to thresholding, let us talk about the histogram and how we are going to decide our thresholding value using histogram. So for histogram, first we have to import the library, matplot library, pyplot.splt. Then we will read our image using imread function of OpenCV, and then using the calchist function of the OpenCV, we will use the first parameter, that is the image. The second parameter 0 is the channel or the color of the image we want. As we want the grayscale, so it is 0. Then third parameter is the mask. If we want the specific region of the picture, then we will use that mask value. Otherwise, we will set it to be none. Then fourth parameter represent the bins or the levels in the histogram. And the last parameter of calchist function is the range of pixel values to be considered in histogram, that we have set from 0 to 256. And using the PLT function of matplot library, we are going to draw our histogram. As we can see in histogram, there is spikes in this region and there is spikes in this region. So if we divide this whole histogram from 120 or 130, we can segment the image from as background and foreground. Okay, so let us take 120 in this video. Okay, now for thresholding, first we will use the imread function to read our image. Then we will convert the color of the image from BGR to grayscale, because the threshold value will only consider the grayscale images. Now using the threshold function of the OpenCV, we are going to make our threshold of our images, in which the first parameter is our image, 120 is the threshold we have decided, then 255 is the all pixel value, and last is the thresholding method we want to implement. Okay, so here we have implemented our thresholding using the threshold function, and the value of threshold is going to store in the retention variable, and threshold 1 will store the output of our function. Then using the CV to IM show method, we are going to print our original image, then we are going to print our binary threshold, and then we are going to print the inversion of our binary image. Okay, now as we have used the IM show function of the OpenCV, which takes the memory to show our images, so we have to ensure that we deallocate any associated memory after usage. For this we use the wait key function, which will keep the images on the screen until the user presses 27, and then it will destroy all the windows and deallocate all the associated memory use. Okay, so let us check the output. The next thresholding technique we are going to use is the OTSU thresholding. OTSU thresholding is actually the optimization technique in the binary thresholding. In using the OTSU thresholding, we can optimally differentiate the foreground from its background. Okay, so in this we just one changes is needed, that is, along with the threshold binary we will add the threshold OTSU function also. Okay, let us see its implementation. So this is the OTSU threshold result.